We just go back in time like they do in Star Trek.
There. Okay, so now, imagine if you will, 7:55. So definitely fire hose that hour, right? So I want to give folks a chance to ask any questions where they feel like I should clarify something before I start going into pretty much pure Java for a while. And then we'll catch back up with DNS before we end. Any questions unresolved? Yeah?
I didn't really get the C name and A name.
Sure, and hardly anybody does. So, so the thing is, if you do NS lookup, right?
Yeah.
It's just basically going to try and find you one of those. And the difference is the type of the information that you're asking for. Most people don't know, or they don't care. They know that maybe DNS will eventually come to an IP address, and that's the important part. CNAME allows you basically to take one name and alias it with something else. So how many folks do virtual hosting on like an Apache server or something? You might have multiple websites on the same host. There's an example of what you would use a CNAME for. You could have multiple names coming to the same box. Now that box has an IP address or several IP addresses too. But that's some of the ways that you could use CNAMEs. Anytime you're pointing to another name, it's a CNAME. Anytime you're pointing to an IP address, it's an A. That's the difference. Anywhere else? All right. So, okay, how many of you Googled Dagger instead of going to find a beer? All right, it's fair. It's not an easy one to win. So, so I think I did a quick poll earlier about those who had used Juice before. I didn't see a lot of hands come up. So if you haven't used Juice, then using that to explain Dagger probably wouldn't help. But I bet a lot of folks have used Spring. Has anyone here used Spring's Java config? Heard of it? Instead of XML, you can use Java to say what your interfaces are binding to and things like that, right? So it's a different way. So instead of encapsulating your configuration in a resource file, you can use a Java class to do that instead. It sounds kind of weird. It's like, okay, well, didn't I start with Java and wire them together? But if you've used the class path, you notice that there's less things you can do with a resource than you can do with like the package protection and the class protection of Java classes. I can make private things. I can make package protected. I can do all sorts of things. If I put under source main resources whatever.xml, I'm going to basically be fighting a lot with visibility problems in ways that I don't have to deal with in Java. Now, is that a good enough a reason? Probably not. People know how to get around these things. But one of the and I'm being a little conceptual because I don't actually have like a why you use Juice intermediary. But let's just say that how many here have had a latent no pointer exception in Spring, or a latent unresolved binding in Spring or any DI system? Using the interface-driven stuff in application context, it is possible for either some resource file you didn't know to override your stuff, or something else to happen, and you would get unexpected results a little bit later than you may have liked. And when you move things into Java, test cases are a lot easier. It doesn't mean just testing Spring and unit tests is impossible, and I'm not even saying it's hard. But I'm just saying that the way that you test a Java object is probably going to be simpler than the way that you would test something that needs to be derived from a resource, whether that resource is JSON or XML or anything else like that. So your options are increased. Juice and Spring are fairly similar as far as dependency injection goes. They have very similar features. Some things evident in Spring are not in Juice. For example, Juice does not have auto-wire. It actually hates the idea. Juice is more strict about how you do things. Dagger is stricter. And if you want to know a lot about Dagger, there's a fantastic article on the InfoQ website. Just do InfoQ Dagger. Jesse Wilson, who's the author of, one of the authors of Spring, who's one of the authors of Dagger now, explained all of the rationale and things like that. The reason I mention Juice so often is it's a Google open source project. It happens to be part of core Google infrastructure. It's fairly well tested stuff. It's a pretty good system. But it does not have the ecosystem that Spring does. And Spring has certainly a lot more things integrated with it. So just because I'm talking about some certain things doesn't mean I universally endorse them. What's fundamentally different between Dagger and any of those folks is that this is not doing runtime injection anymore. This is doing compile time injection. How many of you are aware that you can put annotations on classes and have Java-C interpret them? If not, guess what? You can put an annotation on a Java class and Java-C can interpret. There's actually a service loader lookup thing that I forget the name of the fully qualified interface that you have to implement, but it ends in processor, and if the Java-C has that essentially in its class path, then it will execute that and do whatever the heck it does. Oftentimes that's generating code. So for example, you can imagine you just write a very small class that has no getters, and this will write the getters for you or do other things like that. And so there's a whole bunch of fairly recent utilities that will start writing more of the implementation for you. So you have the advantages of the Java programming language without as much of the craft. I mean, it's writing it for you. It still ends up being a class file. It looks like, hopefully, like what you would have written, but you didn't have to write it. So you can get some of like sort of the groovy-ishness without the groovy-ishness. Dagger acts like that. So what Dagger's approach to dependency injection is that it said, why wait till runtime to fail? Fail at the build. So if you forgot to implement some interface or wire up an implementation class to something that you're using in your graph, it will fail to compile. And that's fantastic. It means that if you actually look at the code of your dependency injection system because you're trying to debug, you don't have to be like leveled up or have some, archaic black T-shirt, and a very long beard. Like there's none of the sort of icons of extreme, I can get through anything, the most mystical code ever to figure out how Spring's doing this. Like that's not the case when your system is very concise in what it does, and also very specific about what it prohibits. If it writes code, then you can look at it. How many here have did JSP development and looked at the servlet code that the JSP might have generated before? In Tomcat, right? So you can do that with Dagger. So instead of like guessing or having to find like the one Spring committer that's in your social network to figure out what the heck happened here, you can look at it and you can see what it literally did, and you can actually change that class when you compile. So I'm not saying this is the holy grail, but this is the promise that it's trying to deliver. And so I suspect some of you, if you can't see this, it's square, the credit card on top of iPhone thing. So the reason why, some of the rationale for redoing dependency injection is we all have this problem where, like for example, I'm so nervous because I forgot my charger. That's the problem of mobile, right? If people write apps, they drain your battery completely. You try and do it too much in your code, in any mobile app, it's going to be dead. And so you want to make sure that you write the most efficient code, the least amount of it possible, with the least amount of magic and runtime tricks. if you can manage that, and you can do everything at compile time, guess what? It doesn't have to be done at runtime. So your mobile apps that are also written in Java, if you're using Android, which that's not, would have the advantage of what you've already computed and verified at runtime. If you remember how Java itself works, there's the compilation is actually verifying the integrity of the class files in doing some work. Of course, with Hotspot, there's lots of fanciness going on, even after you've got flight code. But let's just say if we agree that there are some validation checks that are happening besides just changing Unicode this to Unicode that. So these are some of the things. So Dagger is a very interesting part. It leads to very small libraries. It's notably not mentioned as a good server technology choice. So for example, probably not your best choice to slap between this and Hibernate. Doesn't have the ecosystem. Runtime is much smaller an issue on the server. I know at Netflix we have servers that take 20 minutes to start up. Do I really care about saving 1 minute?
Talking about draining your battery.
Yep. So it's not a golden hammer, but it's pretty interesting. So inside of Denominator, we wire up things with Dagger. So if you're not familiar with doing this sort of like routing dance, I'll walk you through it. So say if you're doing binding in XML, you would probably have an interface someplace and some element or attribute, and then you would have the implementation class, or it's a factory, and you have the parameters to the factory, and it would be modeled like that. On this side, you're really talking left side, right side stuff. So left side is what you're trying to export. Right side is what it needs. So left side, I need this interface, Route 53 API. I know I want a singleton of those. And because I need to tell the annotation processor what to do, this is provides. It doesn't happen to just be an arbitrary method that happens to have a singleton on it. So everything that you're providing, you're exporting, has to have a provides annotation on it. That's the only way, which is helpful. There's not more than one way to do it. It's not Perl. There's only one way to do it, and that's to have a provides method. If you do like Control-Shift-G in Eclipse on provides, you'll find every single thing in your code base. It's actually possible when you're looking for that bug about what's doing what. Right side could need nothing. You could just new the object, send it back. Right side could be something you've already bound left side in another method. In this case, I am using a generic type of supplier, something with a get method, and that's a supplier of credentials. So this is JCL's code, the other project that I spend a lot of time in, and I know that I want to give it a dynamic credential supplier. Why dynamic? Because what if I change my access key? What if it's expired or something like that? It doesn't really matter that it is dynamic, but I just say my contract is I need credentials coming from someplace. That's the art of dependency injection after all. I don't care whether that's coming from a file. I don't care whether that's coming from properties or command line entry. I just know I need it. So this is dependency injection, how it looks in Dagger. It actually looks exactly the same in Juice because it's the same annotations. This is JSR 330, I think. So Spring Java configs, same annotations. So you can use that same code. Now, it's not enough to complete your application because JSR 330 is a very under-spec spec, but at least this part's workable. Now, one of the things that's really helpful, how many here have ever gotten into singleton trouble in dependency injection, where something has a too granular lock, because they're trying to make sure that this thing's done only once. And, if you haven't, how many people have had a too coarse-grained lock in any system, database or otherwise? You lock a table, you meant to lock a row, you meant to lock a column, whatever it is. We've dealt with locks before, and you have locks in dependency injection too. And so some of the things that are very hard to do at runtime that can lead to extremely long initialization times are excessive locking. So if you have compiled some of the things that would otherwise have to straighten themselves into a DAG, into some graph that can be resolved, imagine if you did that at compile time. It doesn't have to do it at runtime. Imagine if it doesn't even have to look for cycles in the graph, because it's impossible for it to have a cycle in the graph because at compile time I verified it didn't. There's a lot of things that are very powerful about the compile time stuff. Wait, space. Next. I don't know what that was supposed to be. Denominator model. So I mentioned the first quirky thing, which is Dagger. Another quirky thing is how we deal with model. So this may feel uncomfortable. In Denominator, we decided that all extensible types are forwarding maps. So, for example, instead of relying on some serialization engine to always do things the way you think it should be done, we limit ourselves to the primitives that are available in JSON, essentially like integer, boolean, string, list, and a map of those things. And by contract, all of our objects are then a forwarding map. So I put an interface name, maybe it's record set, and I could, if that's a mail record, I would have a normal Java getter, but I could alternatively just say the map form, the thing.get, whatever that is. So every accessor has a corresponding key. The reason that's important is when you're mixing back and forth through different languages and Mongo and everything else like this, your lingua franca is really JSON, often enough, or something like it. And you're always transferring to and from maps. Like, maps are commonly used in dynamic languages. We're closer and closer getting to like destructuring form, probably even in Java. Definitely in languages like Clojure, we can pluck off keywords, and of course, Groovy has keyword argument support, stuff like that. So there's a lot of ways for us to look forward and understand that probably map forms are handy. But it's definitely the case it's handy in us. The reason also is that I can say by contract, if I don't know what a special profile is, I know it's a map. So I know I can persist it in Cassandra. I know I can persist it in Mongo. I know I can render that as JSON and not lose data. So I basically am just saying here, we're punting the extensibility concern and basically just setting up a contract for how we behave. We behave by JSON rules because we don't have the JSON spec in Java yet. We use map. So that's the thing that might make people feel uncomfortable.
So all these extensible types deriving from hash map or similar?
It's literally in the library Guava. It's called forwarding map, and so it handles the implementing all those weird things. But effectively, all the types are immutable anyway, so we don't have to deal with most of the junk stuff. I can show you class too. Profile. I told you earlier that special things, like some record set like www.netflix.com might be a different name if you're coming from Europe versus coming from US. Profile is basically our way of saying there's configuration or metadata about this thing. So the record set is an object, but it has tags, and there's very important information. Maybe it's a health check. Maybe it says that in order to return this record, you need to pass HTTP GET on this URI path, or else don't return it at all because you know there's some problem somewhere in the stack. We use the word profile to describe this. And so the resource record set is, of course, a map. Profiles is a list. And if we believe what we said earlier about everything extensible deriving from map, guess what? That's a list of maps. Okay? So if there's nothing in the profiles, it means it's normal. It means we don't have to take special action on it. Little rules like this make it very easy to route things and also understand if I can I move this record from Amazon to Ultra DNS and back without losing data? I can tell that very quickly from this information. And then, of course, like I said earlier, I could, I can access everything as a map, but honestly, I still want to know the schema, and I prefer, because I'm writing in Java, to use the Java class format as my schema. So we have a type code system. So on the extensible types that are leaf types, which are going to have a lot more variance than our top level types, we have a special field call type, which in the Java class is transient. So essentially, we know to ignore that when we're working with Java. So in this case, it might be geo. It might be weighted. It might be health check. It might be something like that. It's just extra information about this Java object. So the other image, which was artfully designed, was taken to create this even more sound image. So essentially, part of the managing the availability is managing availability based on who the requester is, and because even though I said that latency-based routing doesn't guarantee me who they are, if I know who they are, I probably can still put them in a better place. And maybe I can have two optimizations, two profiles, one for latency, one for what flag do they hail, in their elementary school class. So in this case, for example, we have California. Is that New York? Yeah, I think it's New York, right? I think I wrote this during baseball. But at any rate, let's just say that east and west. So we want to make sure that we use all the information we have to its best. So if I know that the user is identified as California, then I'm going to make a guess, and I'm going to route them to California servers first, even though they might be visiting New York at the time. They'll just get redirected, and then they'll lose a hop or something like that in the first request. But we try to use some sort of intelligence to figure out where they're coming from and get them started. We actually have another service in Netflix called Geo, and that's the real database that gets much more granular than what DNS gives us. There's a fun fact about DNS. It's very hard to tell the difference between a user and their service provider in DNS. Because who's actually calling to make these questions? If you ever go into your DHCP configuration on your laptop, you're going to find your DNS servers are probably the ISP that you're using. Maybe you put Google's 8888 server there, right? But it's whoever's doing the recursive query is actually the one that's going to hit Netflix's server directly, most of the time, unless you're very fancy with your configuration. So that means that we know more about your ISP than we know about you when you're asking for the name Netflix.com. That's one important thing to notice about the way DNS works. There is extended DNS, of course, because it's not an uncommon problem. It's certainly been well discussed. And so, for example, the Google DNS servers support extended DNS metadata, including the client subnet information. So they can get basically forward along, sort of like the X forwarded for header. If you've ever used HTTP load balancers, which have a similar problem, you can just pass along the subnet of the original user. The problem is that all the DNS vendors seem to be very opinionated. And some don't like one spec, and they like another spec, and none of them are all finished anyway. So if everyone is not passing along that header, it doesn't really end up being that useful. Because if one of these guys strips it, you're back to the ISP again. So,
But excuse me,
Sure.
why you don't want to go to ISP? Because this is the part that I'm connecting to the main network, and I'm on the edge right now. You can detect that one. And your job to find out closest content delivered network, maybe Akamai or similar companies, and start streaming the information from there to me. So why do you care where is my specific DNS location behind the service provider?
Well, good question. So it's what are you optimizing for? Sometimes we're optimizing for the product team. And the product team are more interested in their zip codes than they're interested in their ISP. Because their ISP could be a regional ISP or something like that. And so, and again, like I said, there's two guards. There's a lot of technicalities in the way the servers, they can boot out. By the time it actually hits the web servers, they can boot them out because they realize they recrossed their IP address and it wasn't what they thought it was supposed to be. But it's mainly, this is all about traffic management. And so there's multiple reasons why we might want to direct traffic. And part of it could just be product related, could be content related. Maybe content's not legal here and that particular ISP is too vague about what it is. So, okay.
Did you get that information on the client side?
We do. And so when I say there's technicalities, by the time it hits actually the servers, they're cross-checked with our Geo database that actually looks at whatever the exported for header, HTTP header came in as. And of course that could be slightly unreliable, but it's a lot more reliable because we have a lot higher control over whether that's propagated or not. And that would have their IP address, and that would basically be, I believe we use Akamai's Geo IP lookup service, which is a UDP service. And so we get like a bunch of updates about like, give me an IP address and tell me the most specific information about it. And we have a service that we manage to share that information across all of our services. That's the answer to your question.
So would I get around it if I would use a HTTP proxy or a SOX 5?
If you use, well,
SOX 5 specific.
So you're gonna have what basically is most important is if you want to understand how it's gonna look, go to what's my IP or whatever some website may have. That IP that is returned by that is likely to be the one that's going to be forwarded and are going to be cross-checked against the Geo service. You're also authenticated at that point. So there's also other metadata that will be crossed. For licensing reasons, Netflix has to do several different types of cross-checks because a lot of it is content rules. It's not perfect. There's a small fraction of a percent that subvert Netflix's stuff, but most cases it can get reasonably precise. I mean, if you ask a product team what their dream world would be, they'd probably ask for the house. Like, I want to know what house this person is, and I want to know their kids' names. Have joking. But seriously, that is a joke. But the precision request could go infinitude from a product perspective. So, but the technology we have and the metadata we have is largely centric on the IP address. So, for example, the Geo stuff is really what's the fidelity or the precision of the Geo table here versus the one we have here. We have higher fidelity here, but we probably prefer it up there. So some of it we might actually have higher technology behind our firewalls that are actually installed on the services. So the Geo profile is type Geo. You might imagine the group if you're using this. So Geo support works read-only mode in Dynect. That will be changed to write soon. We use Ultra DNS for most of our services that would end up being connected to by a client directly. So the maintenance level is much higher there. Also, these are backed by Amazon load balancers, and since we're now deploying more load balancers in more regions, we have more maintenance to do. So we make up group names like US and like everywhere else, or we make up our own names to identify the group of territories that we're interested in. And this is something you get to choose. The territory list you cannot choose. You get whatever they give you. So in the case of Ultra DNS, there's 300 potential choices. And you're just thinking about I'm putting a whitelist on top of it. So it can say all of US or these states or all proxied clients, or all clients are coming from satellite connection. We even have one of them that have like U.S. military base choices. So it's pretty interesting trivia. But the territories list is mask. You cannot choose the values. The values are returned to you by a different API call. You get to choose what that mask is called. Overlaps are not permitted. Most of the providers are strict about that. You can choose to never return a response to a specific territory. So essentially, you can have a blob with some holes in it. So it's cheese for certain states or whatever that don't like Kill Bill or anything. But you cannot say two groups have the same state, for example. And that's mainly because the server needs to understand what you mean. You need to get a chance of giving a straight answer back to the client. If you feel like you need to overlap things, it probably means you're trying to do load balancing. And that's fair and fine, but that you would use load balancing profile for as opposed to overlapping geo territories. It's just, you can get the same thing done, different tool. And, oh God. This is example code. Can anyone see this? Yeah. Okay, all right. So the Geo API, first off, the Geo API is a optional feature. Literally, we use the Google Guava optional type. Optional type is a generic type of whatever your thing is. In this case, Geo API. The optional contract says you can tell if it's present, you get the value, or you can do things like optional.or, which allow you to do a fallback if, for example, that service is not available. So, for example, in Netflix architecture, we have a lot of fallback logic because some service might be completely down. So we would have a chain like or explode. We probably don't do explode that much, but you want to be able to fall back to something. So optional would allow you to say, okay, this DNS provider doesn't have Geo. What could your contract with your client be able to do if that was the case? And it could be not available just because your account does not have access to Geo, or that service is down. So sometimes the architecture behind the services are, there's a different set of technology supporting the advanced records than the normal records. So you can still work in a degraded mode and do maintenance for your normal records with the Geo completely down. So these are the sorts of things you have to think about in architectures that have advanced features. Advanced features they're not always brittle, but they could be. We have helper utilities. This is a static method, and this basically says, I need a function that will coerce or error. And I'm going to coerce to this type Geo, or I'm going to error it out. It's just a shortcut. I told you these things are in maps. So what it's going to do, it just knows to look it up and return the Java type as opposed to having me deal with maps. So we have like little shortcut features to be able to do these things for you. This filter values, there's a lot of Guava code. Guava is sort of like the early version of Lambda, but not because you still have Java to deal with. But there's a lot of functional programming in the Guava library. If you like that, then you might like this. If you don't, then you won't. But filter value says, take this map and make me a new map out of it. That's a result of a filtering function. My input map is the regions inside of that Geo record. And my filter function is a combination of not equal to California. Does this make sense? So this is a filtered multi-map, and multi-map is a type in Guava. Multi-map is used for that terrible check null thing we always have to do when we have a map whose key is a string and its value is a list of strings. Multi-map hides that dance, but it's still, at the end of the day, the same thing. It just takes the crap out of it. So then I update, and I basically update name, type, group with these regions. And so normal records, you can identify that set by the name and type, mysite.com, CNAME. If you get to a special records, generally speaking, you need something else to serve as a source of uniqueness. the case of Geo, the Geo group is what differentiates them. Questions? That was pretty thick. And this is probably not logic people needed to go back and do home right now. But this is how we literally do our maintenance. So, for example, when we're rolling in a new, say we want to make one site have a higher resiliency. It's currently on East Coast. All the states are being served on East Coast. What we do is we create a new site, a new load balancer, and allocate it no regions. Then in a maintenance window, where everybody's ready to turn it off, we cherry pick states 2 at a time. We move those states to the new guy. Watch it, monitor it, wait for DNS propagation delay, which might take 2 to 10 minutes to happen. Look at the API graphs and see if there's any errors, increase of errors, whatever else like that. Settle, okay, product team, you good? Okay, fine. Pluck another 2 states until we get 25, 25 plus military bases. And that's how we do availability migrations. And we've been doing these all for the last couple of months, site by site, making each one more resilient to zones. And so in this case, we're using the Geo stuff, which is sometimes used only for the purpose of licensing or whatever, and we're using it as a higher granularity to do migrations. We could do the same thing for software migrations. And so we could say, we're going to canary New Mexico, because I don't have a nephew in New Mexico that might be watching Netflix right now. So I'll use that state, right? I mean, but whatever your algorithms are. But in case you're curious, Netflix infrastructure team is called Core. And Core is like the folks who rate all of our stuff to deal with the reliability of our services. And they have a way of ranking the states, and there's an algorithm to figure out which ones have what traffic. And so they're basically sorted, and then we pluck them off. And then when we get 50% traffic based on these aggregations, it's not exactly, but we'll stop. And that's it.
I'm just curious, why don't you guys use a rules engine to evaluate these things?
Well, you have rules engines. I think that you mean for doing the ranking?
For example, yeah.
I don't know actually if they're not using the rules engine for that. One thing I've noticed is that the more architecture stuff we do, the more rules engine-y things become. But it doesn't necessarily mean we have a lot of orchestration processes. But for example, we have some work going on to predictive auto-scaling. And that basically is going to have to look at previous and current trends and be able to figure out whether or not it makes sense to start pre-bootstrapping servers because we know that around this time, based on these specific rules, things would happen. So Denominator is actually a fairly new system. So we're actually, right now, in a process standpoint, we're probably going to be a little bit less automated about everything quite yet. But I don't see a reason why we wouldn't end up having a rule, particularly for migration rule. Because, for example, the process is very repeated. And even the way you do migrations, I asked one of the guys, Jeremy Edberg, who used to do the production for Reddit. He's our core lead right now. And basically, he said the process is sort of like this. You get, you're very slow and apprehensive, and then after you get through a certain period, you have more higher confidence, and so things start moving faster. And then when something goes wrong, back. So like rollback might not be as graceful as rolling forward, but all of these things, confidence levels and everything, could actually be evaluated by the rules. I agree with you. Airline is another gadget. Airline allows you to make Git-like CLIs. For those of you who do not use the Git command line tool, imagine any command line tool that has like minus this, like Java, for example, Java minus version or minus XMX, whatever. It might have short and long form. It's different than like your JARGs type of stuff because it's actually includes writing the help statements, the whole shebang. Airline is a bit of a sleeper project because the the team don't do a huge job of promoting the project. But Airlift is made by some folks that currently work at Facebook and other places. Dane is one of the guys that works on this. He's the Geronimo app server back in the day, if anyone remembers that, author of that. But there's other folks like Brian McAllister, who's a pretty interesting person, especially if you ever have to deal with native Java to C bindings. Works on a lot of cool stuff like that. So if you go Brian M on GitHub, Brian M is the founder of this particular project. And our command line looks like this, which should look very, very familiar to someone who is a network administrator probably. I'm going to be able to do things and have feature, command groups, stuff like that. You can bang it into a shell script, right? This is another reason why we try to tune the bootstrap time denominator to keep it as low as possible, because I think the magic number is 700 milliseconds. If you can start something within 700 milliseconds, somebody banging out command lines won't notice. When it starts getting to 1, 2, 3 seconds, they're like, oh, this must be written in Java. So I did an experiment. Our mock provider, which only uses Dagger, can actually start in, I think, 200 milliseconds. But if you do any network call, we currently use Juice, and Juice takes a lot longer to initialize than that. And Spring, of course, would take longer. But Denominator is a command line package as well. It's available on Bintray, I think is the name of it, not Bintray. Bintray is like a file upload package service. And how many here use MacBooks or OS X in general? How many here have heard of Homebrew? So you could do brew install Denominator. So we have Denominator formula. What's that?
What about ports?
We don't have port. But this is actually interesting. This is a jar file. We made it executable. It's a very interesting hack. So basically, if you're interested in the hack to make any jar executable, here's a process in short. You write a shell script with 2 lines in it. One, it says like sh or whatever else like that, and then it says like Java blah blah blah. I think $@. The jar file is basically a normal file. You cat that to the end of the shell script, and you make that file executable. And now you can // the file and put it in the path, and it'll work. And if you want to know how to do that in Gradle, I have that in Denominator is using Gradle as its build script. If you want to know how to do that with Maven, Brian M has a project called Really Executable Jar. It's literally called that. You Google Really Executable Jar, that will find it.
Okay.
Anyway, fun stuff. So the CLI builder is this. It's another one of Brian M's wonderful things. You put annotations on it, telling it short and long form, and how the help statement will look. And random clicking around time. So you guys tell me if you want me to randomly click on something. I could show you like what our dependency graph looks like, because you've probably used Spring. What does it mean when you actually compile something? I thought it was pretty interesting that when you compile it, you can actually process it at the same time. So for example, Dagger will write a dot file. Folks don't know what a dot file is. Basically, you can make graphs, visualize them with a graph or whatever your favorite tool is, or Dotty, which is the name of it. And that can do something. I can show you other parts of the code. I can randomly click on NetflixOSS. And then after that, I just need 5 minutes for last minute information on Cloudflare. So.
I have a question on that. So how much compiler increase for the sorting of the?
Not noticeable. What's noticeable is if you have a new library that is trying out the idea of doing compile time annotations, you'll probably get terrible error messages. But Dagger's pretty good. So.
I have a second question. So on third-party application integrate with Neflix API, does it still go through the denominator?
Yeah.
At runtime, does it still go through the denominator?
Yeah. So right. So the compile time, all it does. So when Denominator is being built, what's happening is that it has a combination of Java source files that I wrote and Java source files that were derived from the files that I wrote. Those are compiled together and they end up in the jar. So I'm going to do some random clicking and show you that. Okay, we good?
Visible.
Alright. So let's go to Denominator Core. By the way, of course, plug, if anybody's interested, you don't have to actually be interested in DNS. If you just like the toys that I've talked about, you can still hop around. I'll put in some links. You can know nothing about DNS and just hang around, do stuff. But if we do the build directory here, I think I've got it. Good. So here's what the classes are named. $$ something. Why $$? Because dollar is an inner type, right? So if you want to make sure, like I don't know, sometimes people might double check an if or like put the parens in when you know operator precedence. That's the make sure, right? The make sure of Dagger is the $. Dagger is very interesting, and what's interesting about it, I mean, obviously I think it's interesting, but what's also interesting is it's not just compile time. Dependency injection. It actually has a fallback to reflection, just like Spring or something else would use. So if you're using TestNG or JUnit or whatever, and you're not actually running Java C, right? This would only be picked up if Java C is executed. So and then you have it back and it's recycled through the class path again. So it has a fallback to runtime injection, which you don't know exists, but you know it's happening because you can run your unit tests and you change things, and it still works. So there's one small thing about this. It means that there's two ways something can happen. Is it that I'm getting the compiled, injection code, or is this being interpreted from reflection? If for some reason I had somebody did some weird jar filter thing in an ant script and stripped out my special classes, it could just be reflection, like your processing time, right? So, but at least it will work if it's not there. So it's very interesting. But here's for example what an inject adapter looks like. Let me look at a fairly simple one. Zone API for my mock provider. Oops. Oh, jeez. Probably. Yeah. This is the same thing you get on JSP. I was right. Please don't edit this one. So, by the way, if you're interested in how this was written, there's another library called Java Writer. That's the thing that wrote this file. So you can write Java code to write Java code. So basically, blah blah blah, some boilerplate Java doc for you. But then, in this case, I'm implementing the type provider, which is just something that has a get method. And this is the same thing as in Spring has. If it doesn't have the same interface, it's going to be almost the exact same. And then what am I providing, right? It's also supplying a binding, which means that what implementation is bound to this type. And definitely people who have been in technology for more than a couple of years love this term. Like how am I linking the bindings together? At any rate, what's happening is that I have a hook to get the dependencies of this binding, so I can basically sort out my tree, make sure that I create the ones that are needed first. And then when I'm getting my mock zone API, what am I doing? Nothing fancy. There's no weird reflection going on. All it's doing is it's calling a constructor. It's calling a constructor and it's passing something to its constructor, whatever data happened to be. So, I can look up whatever data was. Data is a multi-map. So whatever I have bound to this multi-map thing. So I can go through and I can basically, what this does is it allows you to understand, and you can look through the files and you can figure out exactly what's going on. And there's no reflection to make this more difficult than it has to be. It doesn't make it easy, but it's not more difficult than it has to be. And what I like most about it is this. If you do this properly, you can actually get, look at a file that shows you your entire dependency tree. So let's look at the mod provider. I know before I run this thing what everything will resolve to. That's very hard to do in Spring. Very, very hard to guarantee this. So, do I have a lot of information for the way this is rendered as a dot file? Yeah, maybe not. But I've got a pretty good sense. What does this also tell me? How convoluted is my object graph? This one might not look too bad. Actually, I think it's pretty good. I mean, you can, if you ever look at what things actually wire to, it can be far worse. So I'll show you one. Here's Auto DNS, which requires several subcalls to do like a single command. So this is its object graph. And now, it's still actually not terrible as far as object graphs go. It's probably somewhere in the realm of unreasonable. But I can look at this from output of Java-C. I can get a dot file, and I don't even know the project. I can tell, without asking somebody or running find bugs or whatever, just visually look at the complexity of this app and understand where all of its dependencies are. And if any of these are unresolved, Java-C will break. So what does that mean? At first, you're not going to use it for properties. You're going to find some other way of getting properties into the system, things like that. But you can definitely tell the state of your library. And so that's fun clicking to. I'm going to go back because I know I've taken plenty of time here, and just show the progress. So here are the categories. First off, how many people have not heard about the monkeys? Anybody know what the Neflix monkeys are?
Chaos monkeys?
Chaos monkeys. Simian Army. Simian Army is a collection of basically cron jobs that go off and they either help or they hurt. It could be like gremlins, but essentially there's the first one is a chaos monkey, which would kill Amazon instances with various degrees of randomness to make sure that your applications can continue in production without having all the servers up. Why? Because servers will die. Wouldn't it be better if they died while you're working instead of 4 a.m.? Because then you can actually figure out the root cause of your architecture problem that allows it to not survive a server outage. There's Chaos Gorilla. Takes out a load balancer. So it takes out a massive amount of servers. Chaos Kong takes out a region. There's more helpful monkeys than that. Those are actually very helpful. There's a new one called Latency Monkey. And this is really fantastic for those of you who work with web services. So Latency Monkey means you can either inject on the client side, and by inject I'm not talking about Dagger, on the client side or the server side, latency or errors between web services. So if I know that, for example, I get random SSL cert expired problems in my apps and they take massive tolls on all of my infrastructure because somebody forgot to update their JRE, inject it. See what happens. Can your app survive it? Should it survive it? Yes. It should survive it. There's nobody out there in the stakeholders meeting that's going to say, oh, sorry, it was a child update. Yeah, no problem. Yeah, that outage was okay. That doesn't work, right? So this allows you to inject problems you know about, including latency, particularly high latency. Helps you find problems where you might stack up too much, or a server could run out of threads, and then different types of problems you can do simulation. There's a conformity monkey. Conformity monkey will kill services that aren't identified properly. Because when you're in production, obviously you want to know that you can identify all the critical components of your architecture. When there's a problem, you can know the difference between what should be up and what is up, things like that. So if something's named incorrectly, you can't identify it, it's not registering itself in Zookeeper or whatever else like that. And most of these things are not quite as brutal as they're described. So for example, people can opt out. In Neflix, you can do that. You can say, warn me, don't kill it immediately. You can say, only kill servers at, at 2 p.m. There's a lot of tweaks with it. So anyway, monkeys are that. So a lot of people are happy about monkeys. You can design any monkey. Monkey ideas, just think of it as something like, man, I wish something was checking that. That's the sort of things that make monkeys. Portability enhancement could be different cloud, could be something that's Java but is really functional. Maybe that should be Scala, or maybe that should be Clojure or something like that. You can find a place to make something more portable. It could be runtime specific, or it could be cloud specific. I can read you the rest of these things, but a lot of them are tacit too, or let's just say not tacit, subjective, more subjective. Everything's subjective, but what's the idea of code quality, right? There's a big one. Defining code quality might be the answer, right? We have obviously in Netflix, I'm sure we're using similar tools to other folks. We have our check style, we have bugs and stuff like that. But what does it mean, and how could we actually, as a company who's putting out a bunch of open source projects, how do we make that more succinct when people have discussions about code quality, and how do we get the guidelines out there? So anyway, take a look at it. Judge's Choice Award is a catch-all. It basically means that all these are $10,000 each. We didn't want to prevent somebody from getting a prize just because we weren't clever enough to figure out what they were going to think of. And that's what the Judge's Choice Award is for. So the process is here. And it was opened in March. And the close is September 15th. So that doesn't mean don't start until September 1st. All the contributions have to be going to GitHub. GitHub's a very easy source control tool to sign up for, get an account. All you have to do is go on the site and fork our cloud price. Fork basically means you make a copy of it. It has a submission form, and then you offer as a contribution your submission. And that submission would describe whatever work that you're anticipating to do. And companies are doing this. I know certain companies are doing things to integrate their products or to do whatever. It doesn't have to be like a single person. It can be a team of people. It can be something very interesting. And then once it's closed, whoever the awards are that were chosen will be flown out to Amazon reInvent in Las Vegas, put up in hotels, ticket for your significant other if you so desire, and you go to our version of the Emmys. And so that's the deal. The evaluation starts off as conformance to rules. We don't have many rules, but it has to be Apache licensed. It has to go on GitHub. If you put it in SourceForge or whatever, we're not going to consider it. We need to have some way of not giving ourselves a whole lot of work to do, because this is a side job. Code has to be working. If you want this to be chosen, your best bet is actually to show it's working in production. Because Netflix open source projects are they are all in production. So this is not just a toy playground. So if the more viable your code is, if you can't convince one other person or project or company to use your code, then probably you're not going to submit. At least yourself, you use it in production. And the traction part will help you too. It's another way, the same way I just said. Traction can be other people cooperating with you. It can also be other folks using or integrating with whatever you're doing. It's a pretty lively community. Netflix employees are very accessible. So if you have questions as you go along, you're not even sure, there's a Google group for the Netflix Cloud Prize. You can just ask. People are very giving with their time. Netflix engineering sifts through the nominations and then sifts them into the categories if it's ambiguous, and just make sure that the rules conform. And then the judges decide the winners. So what are we doing in Netflix open source? And you don't have to follow this model if you're interested in the Cloud Prize, but this is what we're looking at. Adrian Cockcroft has this sort of like the same thing as a CAP theorem where you can choose two. There's sort of like functionality, scalability, and portability you can have in a system, and you can optimize for only so many at the same time. We optimized for functionality and scale first, portability last. So we're not unaware of the fact that most of our stuff only works on Amazon, but we are working on things like language portability and stuff like that. You can work on that. That's why those categories are there. And we're also working from having just a boatload of little projects to having a platform that we actually are deploying to in production. And what we mean by platform is we mean the things that go from code straight out to scaling service, the whole shebang. Data services, messaging, all the stuff that we use that actually run our platform that can be cohesively put together. And we have a lot of work towards that already. So anyway, that's the spiel on the open source. Now, the takeaway that you can't read here is that Denominator is what we use for ENS. It's one project. It's a new project. It doesn't follow any of the rules of the other projects except we use Gradle. You'll find a lot of different types of projects in Netflix open source. They're used in production. They follow different patterns. Some of them follow the same patterns. They're all opt-in. Nobody's forced to do something. And when you think about open source in Netflix, keep an open mind and share with us your ideas. And if you don't see something there, don't assume that we have omniscient views and we've already considered it. Definitely speak up, and if you speak up and you have some time to contribute to it, you might have a good Cloud Prize entry. So hopefully this all metadata about Netflix open source was helpful. Hopefully you saw some cool tricks, even if you don't use DNS. And thanks for inviting me in.
Just a couple of questions, if there are any.
I see that you guys have a big emphasis on open source. And so let's say that you work for a Fortune 500 company and you think that there are a lot of things like metrics and monitoring that aren't necessarily core competencies, and you would like to convince your management to let you open source these tools. Do you guys have some sort of presentation that you guys use internally to justify this that you guys are sharing, to say, hey, this is why we think this makes sense to put a lot of our hard work so that anybody else can use it?
You mean like sort of giving folks the pitch to their management?
Yeah.
So I would say that one thing that's going for Netflix is that they don't have an agenda. It's helpful. For example, we do have an agenda, but we don't have an agenda to sell corporation software. That baggage isn't there. The brand recognition is there. Sometimes the conversations are easier from the Netflix open source perspective because sometimes companies just haven't entered the open source stuff yet. The participation rules are very easy. For example, Netflix does not actively collect contributor license agreements. we basically go, we've had it legally reviewed, of course, but we don't require certain artifacts that other companies might, especially if they're going to resell software. So, for example, in California, working off of your hours is fully valid, and but I'm not going to be a lawyer here, but let's just say some people have opinions that that's possible to do. If you're trying to actually sort of change the perspective of your company to like adopt either participating or open sourcing something, I would say start with participation because that's an easier fight. And it won't necessarily be a fight, but it could be, so I'm going to use the word. When I, for example, first started open source, it was a California company, and it wasn't that common. The first concerns were like what is the protection about, and is there a chance for someone to accidentally get access to the core IP of the company through this process, or is this just a exit ramp for my top employees to go somewhere else? Those are some of the concerns that might come up. From how do you phrase it, I would say work at the lowest level in the management chain that could tell you yes, and go with that. That's I'm not saying you're going to get a yes at a low level. A lot of times people get anxiety about that type of question, but basically make it concrete. Managers like concrete things anyway. Just say, here's my goal. Here's how I can achieve it. This is exactly where I'm looking to work in, and let's try it out for 30 days. And after that 30 days, maybe we have this other thing we've worked on for our metrics. Maybe it will make sense to work it there. And just if you present like sort of ideas that might be perceived as dodgy, with some sort of a container where somebody can feel like they can control the damage if it gets out of hand, it's a lot easier for them to then either say yes to or find some way to say yes to. That's the best I can do for that one. I know that I've gone to large companies and done presentations. I used to work at Fannie Mae, for example, and they've invited me in to do a chat. And I did a chat, talked to them about what they do. Did it magically make everyone a committer? No. But socializing is very important. And sometimes the most important thing about influence is what is a person advice? What is the advice that they hear when they turn and they ask? And so socializing change happens because not only did you ask the person who has the authority, but also who in their peer group would agree with that. So when they ask to say, is this a reasonable thing? Should we be doing this? That they have also heard about this idea before, and it's not a scary thing. So culture change is not required to participate in open source. You can find ways of containing it to say that this is a project basis. This is not like we're going to change everything. But regardless, the more sort of buy-in that you get, I would say is going to be in your favor. So, and soapbox. But I've done it, by the way. I was the first open source I ever worked at was, and it was actually at Barclays in UK, and it was easier than I thought. And sometimes people don't ask. But the whole reason Netflix even has open source is because somebody bothered to ask. So Jordan a year and a half ago said, "Hey, I think this would be good for Zookeeper. Why don't we do open source here?" It's like, why don't we? You know. So you can get turned down if you ask, but you get a lot higher chances of winning the lottery when you buy two.
Okay, great. Let's go ahead and wrap up the lot. I'm going to present to Adrian an official Java users group again.
Cool.
I think these are outstanding collectors.
Thank you.
There you go.